is Jason Todd. I'm with TimberHP. I'm Director of Building Science and Industry Support. It's been a while since I've been on the Beyond R Value. I've got a great team of folks that have been promoting and discussing and bringing in outside guests. And I'd like to introduce a couple folks real quickly. I'll go through a couple of slides and then hand this over to the folks at Benjamin Obdyke. Just a little bit, little information, rules of engagement, all that sort of thing. Feel free to use the chat as you wish for communicating among anyone on the Zoom. If you could, and you have questions you're looking to have answered by myself or the panelists, use the Q&A. If you'd like to share where you're coming from, any interest in either of our products, look forward to hearing from that. And I believe that this will be recorded and should be able to share that sometime before the end of the week. So I'll just hand it over to Kaylin and Nick, just a quick intro, and then we'll get going.
Perfect. Thanks, Jason. My name is Kaylin Hanley. I'm the Technical Innovation Manager for Benjamin Obdyke. So we work a lot with our contractors, architects in the field in developing products and details to really make sure that we can have the best building envelopes as possible. And Nick's going to be with us here. He's in technical support on the inside, and he's going to help looking at the chat. So if you want to ask questions, we're happy to kind of answer those along the way, or if not, we will get to them at the very end. Thanks,
Great.
Jason.
Awesome. All right. So get going. So again, thanks very much for joining, and looking forward to hearing more from Benjamin Obdyke than maybe from myself. But many of you are likely familiar with the product if you've been on the webinars before. First wood fiber insulation manufacturers in North America. Lots of great characteristics and qualities to the product. We are underway and have been for over a year now with the blown fiber TimberFill, similar to based on a cellulose product standard, similar in application, and also have been producing timber bat. Both of these cavity insulations are available in the market, predominantly here in the Northeast and down into the Mid-Atlantic, working towards the Canadian marketplace as well. And just at a high level, we're talking about fire-resistant cavity insulation, exceptional best-in-class acoustics, and something for all seasons. A lot of complexity in the colder climates when we start talking about moisture management and control, which is why I think most of us are here. So looking forward to questions to the group in the future. Cavity insulation alone is not going to solve all the problems when it comes to moisture, although TimberHP is very proud of the fact that we've got a bio-based material that is very good at mitigating some concerns and issues when it comes to moisture, but we need a little bit more when we talk about those assemblies, and I think we'll get into that with Kaylin and Nick's presentation. And just so you know, I know plenty of people are often asking about our third product. We should be restarting the board line and moving towards that continuous exterior product towards the end of the summer into fall, hopefully ready for that fall increased demand. And I suspect that Benjamin Obdyke could come out again and join us and talk about some exterior products as well. We're going to focus on some of the interior things today, but again, not a standalone product when it comes to managing weather, moisture, airflow. Can certainly help and mitigate some of that, address some bulk moisture issues with the materials that bind the board. And that is one of the great competitive advantages that we find at Vapor Open, but also mitigating some bulk moisture issues for sure. And not to stress this too much, but I think it is important. We're really a drop-in replacement, or see ourselves as a drop-in replacement for above grade applications, and really very focused on the building science. We try to to pay attention as much as possible, best practices as we get further afield in climate, and to that point have a builder's guide, which is sort of a high level focus on building science with the support of Building Science Corporation, Dr. Joe Stubrick, some guidelines and recommendations about best practices when it comes to climate zone and application.
Hey, Jason, I got a question. First
Yeah.
question in on the chat. Can the TimberFill product be wet blown for dense pack wall cavity applications like cellulose?
Sure.
That,
It is not
that
something
comes
that
from
we have.
Marshall.
Great, thank you. We have not focused on that because in our particular climate, that's typically not an application done. There's a few installers in the area, but we have talked with a few machine manufacturers. They've experimented, and yes, it can be done. There's no added binders and like you might see in some other cavity insulations, but certainly it could be done. I think as we move forward and broaden our reach, we might see applications or a demand for that application in the future. Thanks. High performance, healthy planet, healthy people, all of those things tied together are the important things when we talk about assemblies. And at that point, I will just say that we are not the whole assembly. We need framing, we need structure, we need racking resistance, we need weather resistance, we need airflow and vapor resistance and all of that. So really appreciate Kaylin joining us for this presentation to talk a little bit about their products, and I will hand it over to you guys right now.
All right, awesome. So yeah, we'll jump on in here and we'll piggyback off of what Jason said. So really with Benjamin Obdyke, we focus on moisture management. And this is something we've been around the industry since 1868 when our founder invented the corrugated downspout. And throughout the years, we look at the evolution of building products and building assemblies. And we have to recognize that our assemblies are changing, they're evolving, we are asking them to do a lot more. So we have to be able to understand the components that are going into these building assemblies. And using a product like TimberHP is a great complement to a lot of different layers that we're working with, because we want to understand the difference between a vapor closed or a vapor open assembly, because we can have a lot of risks that get put into the assemblies based on our choices that we make. And with Benjamin Obdyke, we specialize in exterior building envelope in terms of WRBs and flashing systems and rain screen assemblies, but we've started to move on to the interior. So this is a perfect complement when we're looking at a vapor permeable insulation like TimberHP, and we're going to kind of go through some of the different details. And again, please type in any questions that you have, and we will tie them in as they apply based on our conversation. So when we look at our assemblies, we have a lot of decisions to make. And that really comes down to if we're building a cube or a box, that we have 6 different sides, that on these sides, we have to have 4 different control layers, and they have to be continuous, and they have to be connected, and they have to transition well. And they have to work all together. So we have to look at, for water control, we got to make sure the bulk water doesn't get in. We are more and more likely looking at air control. We're looking at blower door tests that are being done. We have to understand the thermal code based on our climate. So we want to make sure that we can resist the movements of temperature from the inside to the outside, or vice versa, depending on the seasonal change. And today we're going to be looking at vapor control. This is something that can be a little confusing, so I'm going to try to put in some animations and some visuals just so that we can kind of understand the forces that we're working with. That way we can better understand the strengths and limitations of the material properties that we have to choose from. And we're going to be talking in vapor control, and we're going to highlight our newest product, which is called VaporWise. So this is a vapor variable interior membrane. So this is a smart vapor retarder that can be used on the interior or towards the warm side in winter of our building assembly. This is a perfect complement to the timber bats that you saw in Jason's presentation. Can also work very well with a loose filled TimberHP insulation or some insulation that is vapor open. Because with this product, we can, number one, can control water vapor as it moves through, and it can also be detailed for air control if we're choosing an interior air control strategy. So a couple different ways that we can look at this. And the biggest criteria that we have to understand in our building envelope is there's a misconception as we talk about what a material is. And one of the biggest ones that we run into is the term vapor barrier. So this is something that is thrown around a lot, and I've heard it being used with house wraps being a vapor barrier or insulation being a vapor barrier. And we're going to go through some of the numbers as to what that term actually means and why having a vapor barrier or a vapor closed material in your wall assembly or roof assembly can be very risky. And we'll go into some of the details as to why that is. But what we're trying to show is that the industry is moving in such a way that everything is scrutinized. Everything is looked under a microscope based on the details that we're changing, because everything has to work together. And historically, whether it be in the 70s, 80s, 90s, even early 2000s, we as an industry have made a lot of mistakes. So we see a lot of failures, we see a lot of wood rot, and we have to understand, we have to learn from those. And one of the best ways is to create an assembly that is vapor open. So we also do a lot of work with Joe Stiebrick and the Building Science Corporation. And this is really a great quote from Dr. Joe. If anyone's familiar with Joe Stiebrick, great resource, great character as well, where he really tries to make things more relatable in terms of why we're looking at certain assemblies. And this quote is just really going to say that a vapor barrier, which is vapor closed, is intended to stop the material from getting wet. However, when you do that, it also stops the drying potential. So we want to look at the risk of that overall assembly and understand when we want to use a vapor barrier, vapor closed, or when we want something that is vapor open or a vapor retarder. So that's kind of the topic that we're gonna go through, and really trying to help with some of the visualization of what we're talking about. Because when we talk about water vapor, this is all around us. I'm giving off a ton of hot air right now, and that is moving somewhere. So we have to understand what these materials are doing and how these water vapor molecules are reacting. And first is really around the material science. So if we're talking about a house wrap or a weather resistant barrier, is very similar in characteristics to our VaporWise or interior smart vapor retarder, where we have to be able to stop liquid water from moving through. We have to stop air molecules from moving through, but we have to have some kind of a pore structure that allows the water vapor molecules to move through or at a certain rate. So based on the material, based on design or the need, this rate of water vapor moving through can be changed or altered. So that is referred to as permeance, or we'll take a look at the vapor perm, or the perm rating of a material is the passage or how much water vapor passes through in a given pressure or a given sequence. And that's all well and good to kind of think about that, but it's another thing to try to visualize it. So I found this quick little video where we're trying to see what water vapor molecules do. And the concept of permeance is taking a high concentration, those molecules are bouncing around at a crazy speed, and they are randomly hitting the different walls, they're hitting the different molecules. And if you look at this grid system in the middle here, those holes, that's like the vapor permeance, or how much water vapor can move through. So when we have a high concentration of water vapor on one side of this material, it wants to balance out. just like dodgeball. If anyone is familiar that these molecules are randomly moving all over the place. Some are moving through the membrane, some are bouncing back. But what happens in the natural world is these molecules, these pressures, they want to find an equilibrium. They want to find a balance. So if we give this long enough, it's going to find that balance where you're going to have an equal amount of molecules on one side as the other. So that's just how that permeance is going to affect that. Now, if we have something that has a lower perm, then it's going to slow that equilibrium. It's going to be at a higher pressure for longer on one side, and that's going to slowly move through versus a higher permeance. And that all relates to some of the code language. So now this kind of gets down to the point of, is something a vapor retarder or is something a vapor barrier? And these are two critical terms that we have to make sure that we can distinguish, because the physical properties and the result of the assembly change dramatically based on what we're looking for. And in the building code, they call out from a class 1 to a class 3. And this is all based on the perm rating, or how easily or how restrictive water vapor molecules can move through the surface. So if we are very close to 0, or a closed assembly, vapor closed, or a vapor barrier, then we are about 0.1 perm. So very restrictive to allowing water vapor through. So this would be your glass, a lot of the 6 mil polyethylene sheets that we commonly use. This would be your vapor barriers that you are typically using below your slabs of your basement, or anything that is in contact with ground, because we don't want the moisture from the earth moving into our structure. So these are vapor closed. Now, once we get into class 2 and class 3, these become more vapor open. And we have to understand what we're trying to achieve. And we look at a range of a little bit over 0 to 1 perms as a class 2, and then class 3 getting into the 1 to about 10 perms. So this is going to be more of an open assembly in terms of how vapor can flow through it. Okay, these are critical, and it really comes down to, Jason, do you have something you want to add?
Yeah, I just wanted to say that we did get a question in the chat. Charlie had asked if too much vapor moves through assembly, what's the negative effect? Condensation and therefore potential rot was the open-ended question. And I don't know if you had anything to add along those lines.
Yeah. Yeah, too much vapor openness is can be a bad thing. So it depends on the assembly, it depends on the materials that we're using inside of it. So we'll get through, once we get into some of the wall layering, we want to be able to regulate the moisture that's going into the assembly from the exterior as well as from the interior. And commonly from the exterior, we can regulate any excess moisture that's moving from the outside in with our WRBs. So with our house wraps, we can prevent a lot of that inward drive while still being vapor open enough that if it is inside that wall cavity, it can escape. So that is a great question, because there's a lot of membranes that are extremely high vapor permeance, and they typically will market it as a high vapor permed product on the outside of the building is great because it allows the interior of the wall to dry outward. So that's correct. However, vapor permeance is a two-way street. So if it can let a lot of moisture out, that's great. But in the summer, hot, humid times, it can also let a lot of moisture in. So we have to look at the whole equation. And that's typically from our exterior WRB standpoint. We follow the Building Science Corporation a lot with their mentality that between a 10 and a 20 perm on the exterior of the building is a good range for having that balance and regulation of vapor permeance.
Great, thank you.
Because all of the materials that we're commonly using, they have some sort of vapor permeance. It could be quite high, it could be quite low, it could be somewhere in the middle. And basically, that's not a problem if we understand how those layers work together. So I want to take a look at, and we'll see some failures here in a little bit, where there was a common trend in our colder climates that we would put a vapor closed 6 mil poly on the interior of our buildings. And before we had air conditioning, that worked. If we have a climate zone that is primarily a heating zone, where it's typically cold outside for a majority of the year, we don't have a really long hot humid season, that can work just fine. But it got risky as soon as we get into the mixed climate zones, where now we have a seasonal change in which the water vapor wants to move given the pressures. But all the materials have sort of a vapor permeance. And I wanted to pull up these numbers, which were from Pro Remodeler, just to kind of give you an idea on just some of the ranges that we're working with. And again, when we look at the perm ratings, the higher the number is more vapor flow. Lower the number is less. So it's kind of similar to the throttle on your car. So if you have a high number in the perm, that means the throttle's down. So we have a lot of gas moving through, we have a lot of vapor moving through. And then if we get a lower number, then we're kind of idling. We're tailoring it down a little bit. And when it comes to permeance, it's not a perfect silent science based on one material. We have to look at how everything moves together. So in general, Tyvek is a higher perm product, and with HydroGap is our drainable house wrap. We do like it around the 16 perm. Like I said, that helps to regulate exterior vapor pressure from moving in while still being open to allow the sheathing or the wall cavity to dry to the exterior. And then one of the common differences to point out is a OSB sheathing versus a CDX plywood. So OSB is typically a lower permed product in terms of how much water vapor can move through, because it's a lot of different glues that are used in order to hold the material together, where a CDX plywood will typically have a slightly higher perm rating because it still has those layers of the tree, the veneers, if you will, that still has those pores. And then once we get below that 0.1, like a 6 mil poly you see down here, or the peel and stick membrane we'll talk about. So this would be something along the lines of a ice and water shield or a asphalt-based self-adhered membrane that we use for detailing ice barriers. Those are considered vapor closed. But if we look at just the material, that gives us a data point. But we also want to look at the assembly. So if we take a look over here at the chart on the right, so a vinyl siding itself would be near vapor closed, but it's the assembly where there's a lot of air leaks, there's a lot of different joints, which allows for more vapor permeance. So again, looking at the holistic assembly tells us the story of where our vapor profile is in the wall. Because what we're really trying to achieve is a reduction of risk in our assemblies. And a lot of the risk comes down to the potential for condensation in our wall cavity. And has anyone lived in a home with a single pane window? When it's extremely cold outside and it's hot and humid inside, what is happening to that inside of that single pane of glass? Same thing with your iced tea during the hot, humid summer months. You get condensation on that glass because the glass is cold. And that's what we're trying to prevent inside of our walls. So if we can understand how moisture moves and just the basics of things going from a high pressure to a low, just like in that animation where you saw the water molecules moving around, that is trying to find that equilibrium. So if we know where the high pressure is, we know it's going to be moving to that low. If we know where the high relative humidity is or the high concentration, we know it's going to be going away, and it always moves from hot to cold. So in majority of the failures that I've seen, if there's a failure inside of the wall based on condensation or an air leak, it will typically happen on that cold surface. So if we can insulate our walls properly and we can have it air sealed, that dramatically reduces the risk that we have in our wall cavities.
Kaylin.
Yes.
Got a series of comments here with questions. Marshall and then Marianne added in, what differentiates VaporWise from CertainTeed's membrane or ProClima's Intello or Rothoblast Clima Control 105? But before you answer that, Grant commented, turns into a dehumidifier. I think as you were speaking, something converts to a dehumidifier. I'm not really sure about
Yeah,
that
the
comment.
single pane window is a
Ah,
dehumidifier because you have
okay.
condensation on that cold glass. It's taking the moisture from the air and it's bringing it into a liquid state. And in terms of the differences in the products, we'll get to that as we kind of talk through some of the different specifics once we get to the end, and we can kind of touch on some of those different bases.
Cool. Thank you.
And so with the vapor retarder, this is something that is called out in the building code as well. So we have to understand with climate zone that we're building and where is the warm side in winter, because we want to make sure we can control the interior moisture, because we don't want our interior of our walls to be part of that dehumidifier, like the gentleman said, with the single pane window. So when we're looking at our walls, it is always safest, especially in the residential world, in common above grade construction, to look at a pass-through assembly. And that's something that I really love with the way TimberHP allows that vapor permeance to move through it in the TimberFill as well as in their exterior insulation. Because right now we've seen a huge push in the 2021 IRC to move to a R30 wall cavity in a lot of climates, and or a exterior insulation that can dramatically complicate our water control details. So the concern is, if we have a vapor closed assembly, let's say we have a exterior insulation that's vapor closed, what that's going to do, if you take a look here at the designation that is the vapor throttle, we have to look at where is a vapor closed membrane. So let's say right here, if we had a exterior insulation that was vapor closed, our wall is now limited to drying in one direction. If this was vapor closed, it can only dry to the interior, or it can only dry to the exterior based on how it's the wetting event. And that can be a big challenge if we don't get our water control details correctly. If we don't have our windows flashed in correctly with our WRB, this could be a big challenge. And we're also seeing a big push to closed cell spray foam, which can be a challenge if it's not detailed correctly, or if the sheathing gets wet and we have closed cell in the cavity, now it can only dry to the exterior. So we're limiting our drying potential. And that's exactly what Joe Stiebrick said in that quote. When we have vapor barriers in our walls, we are trying to stop water from getting in. But if it does, we are now stopping the drying potential. And that is the whole premise that adds to risk. So we want to always understand the strengths and limitations of all of our materials and how our wall is going to, or our roof system is going to function. Because this is critical to know that in a cold or mixed climate, these driving forces, when it comes to vapor, are going to change based on the seasons in which we're living. So if we were to take a look at our normal winter conditions in a cold climate, we have a cold exterior, typically dry. We have a warm inside, which, based on living inside these well-insulated, airtight homes, we're increasing the humidity levels with showering and talking and cooking. And this is all creating an interior pressure that wants to balance out and move to the exterior. So we need to have, and this is per the building code, some sort of interior vapor control that slows down the movement of that water vapor so it does not hit a cold surface and condense. And that's where a product like VaporWise creates a great synergy with the TimberHP systems, because now in those cold months when the interior moisture builds up, we have a very low vapor permeance that slows the rate of movement into that wall cavity. So if we can control that, if we can limit how much is getting pushed to that cavity, we can now limit the risk of that moisture finding a cold surface. And then the key to having a smart vapor retarder is that that vapor permeance changes in the summer, where it'll actually open up and allow the wall cavity to dry out. And that's really where we're looking at creating these higher performance building envelopes. Our air tightness is becoming a record low on a common day-to-day practice with our building envelopes, which means we are losing our drying potential that we used to have in our insulated and leaky structures. So we have to look at things with more of a microscope than we ever have before. And these all have different causes and effects that we have to understand as we go through this process.
Okay, I got another couple questions for you here. John Skog typed in here, we are in the Pacific Northwest climate zone 4C. Jason Todd would like to answer this question live. Go ahead, Jason. Oh, wait, what?
Go ahead. I just hit a button there. Feel free to carry
on. If our air barrier strategy requires a peel and stick membrane on the exterior sheathing, are we then forced to inward dry?
So we have to understand the differences in our self-adhered membrane technologies. So if you have a air barrier self-adhered membrane on the exterior of the building that is vapor permeable, which so that's something we believe in. So our HydroGap SA is a fully self-adhered meant for the wall. So that can create a great exterior air barrier strategy while still being vapor permeable. So we can still get the outward drying that we really want in that pass-through assembly.
Yep, excellent. And another question here, how do you detail polyiso to be vapor open?
So if you're using a product like a polyiso, which is vapor closed, if it's a foil-faced assembly, you cannot detail that product to be vapor open. You have to put in that membrane or that insulation in such a way that you know you are not drying through it. So in that case, you have to make sure you have enough interior drying potential because that's the only direction that you're going to dry. So and that's why we would prefer to have something that is vapor open, like a timber board.
Okay. Tim Callahan just typed in, he's using timber bat in an R60 plus roof assembly in climate zone 4E. Is a class 2 membrane indicated? And are you saying VaporWise permeance changes? Yes, VaporWise permeance does change based on the relative humidity. But I don't know. I don't know if a class 2 membrane is indicated. I'm not sure how to answer that.
I think that's
so
gonna be
VaporWise
to
moves
code
from
cycle.
a class 2 membrane in the winter months to a class 3 membrane in the summer months. And Todd, Jason, did you have something to say or you want to add?
No, just to follow in on that concept that it's really going to be specific to code and code cycle, but most likely, I mean, I think that's the beautiful thing about membranes such as this with the variable perm, like you just stated, that it can be a class 2 vapor retarder, but then flex as it needs to as the climate changes and moisture loads in the building change.
All right, and last one here, he's just jumping in. Latex paint has such a low perm rating. Doesn't painted drywall really decrease the drying potential to the interior?
I can speak to that as well. I mean, latex paint has a reasonable perm rating, and usually 2 layers gets you sub 10 in that class 3 area. It could even be in an enamel paint, I believe. That may have been indicated in one of the charts that Kaylin had earlier. So a painted sheetrock product doesn't get outside of that class 3 vapor retarder unless there's a ton of paint on it, like there might be in my old house.
Perfect. Thank you. Because and that's critical to know. Because I do believe that there's some vapor retarder paints that might get a little lower, but I'm pretty sure they're all still in that class 3 range. Because if we don't have the proper vapor retarder on the interior, when it gets into this cold time of year and our exterior sheathing is cold, now we have all this interior moisture that hits that cold surface. And that's where we get the condensation, just like that single pane window.
Yeah, and you are correct. There is specifically low perm paints that can fall into that class 2 category, but they're not
Okay,
a
class 2.
standard house paint. Yeah.
Okay, perfect. Thank you for that. So again, there's a lot of different ways that we can build these assemblies. It's just making sure that we have the right products in the right sequence that are going to work for our climate. And this has become a lot more complicated than ever before. I recognize that. So that's where, we are always happy to help. And I know Jason and his team are a great resource to ask these questions as we have designs come up or as we're in these pre-construction meetings to make sure that we are all on the same page. Because we have to look at this all together for these assemblies to really work for the long term that we're trying to achieve. So moisture moves through from diffusion, but it also moves through a lot with air leakage. So if we have an air leak that's moving through, let's say, an exterior outlet, that can move a ton of moisture to a cold surface. So if we have an air leak that's moving to the exterior, it hits a cold surface, then we're going to have significant wetting potential. And that's really why, from the building code standpoint and building science and the way that we're building, we're trying to really focus on our air tightness, because it can have dramatic wetting events if it's not handled, or if we have a leak in the wrong spot, it can carry with it a lot of that interior moisture. Okay, if that wasn't enough to understand how it moves in winter, in a lot of the climates, we have to understand what it does in summer. And this, we had a question about how moisture can move from the outside given a high vapor perm, or is there a WRB that the perm rating is too high? And this is where the answer can be yes. If we're in a hot, humid summer climate, we have a lot of that humidity is on the exterior. And we are now air conditioning our interiors down to a very chilly temperature. So all that vapor pressure wants to move from the outside in. And in the 90s, we used to use a lot of vapor closed 6 mil poly inside of our wall cavities. And that worked for the majority of the time until we started air conditioning our interiors. So now we're making our interiors very cold. So any of that humidity that was in that wall cavity cannot dry through that 6 mil poly. And we were starting to get water condensing, and we were starting to get the carpets were becoming wet on the perimeters of the building because we just had that moisture that was condensing on that polyurethane. So now, we can change that. If we had a smart membrane in the assembly, it can allow that pass through, allowing to dry to the inside and preventing this vapor pressure and condensation from building up. Okay, not only are our products changing, but our assemblies are changing too. So we have typically looked at a ventilated attic space. A ventilated attic space. So now that's working with our ventilation system in the attic, and this changes where our control layers are. So if we're building our control layers, we have now, this is our thermal control, is now going to be the lid of our roof. So we have to make sure that everything is air sealed to increase the effective R value. We have to make sure that our attic is ventilated at the right amount, because this is going to take moisture out of the hot, humid attic space. But we're now moving into a different type of assembly where we see the advantage given different climate zones and different HVAC strategies, where we're going to actually move to a unvented attic space. So now our thermal boundaries change. We're now looking at including the roof assembly or the pitch into our thermal boundaries, as well as our water and air control. So these two different strategies change the way that we have to think about our transitions. And we have to look at, if we do this assembly in this order, we now do not have a natural ventilation system that is going to remove moisture. So now it's risky if our mechanical system is not set up in a correct way to remove the moisture at the ridge. We now see a lot of moisture building up and failures at the ridge system. So it's understanding the forces and understanding the materials. And there's been a lot of movement given the code changes to fill their wall cavity with a closed cell spray foam. This is something that I would caution. It can work, but we're really not looking at the best assembly in terms of reduction of risk, because we've seen a lot of issues with this, because you have to make and create complex chemistry on an imperfect climate, imperfect job site. This is something that is very challenging. So if we have the installation that is not done perfectly, or if we have our framing material that is at a slightly higher moisture content, that moisture is going to escape and that framing material is going to shrink. So we see a lot of cracking, a lot of fissures that occur. So now your assembly, which was designed to be vapor closed with that type of product, now becomes vapor open. And we go back to what Joe Stiebrick said at the very first quote. If you're putting a vapor closed assembly in, it's designed to stop moisture from getting through it, but it also reduces drying potential if moisture gets in. And that's really the biggest risk that we're seeing now, and why we're trying to advocate for a pass-through vapor assembly. Because we also see this on the roof line as well. This is something where a vapor closed asphalt self-adhered product like an ice and water shield is designed for code for prevent ice damming at the eaves and valleys. However, we've been starting to use this on the entire roof deck. So now we're covering our entire roof surface with a vapor closed self-adhered membrane. The thinking that if a little bit is good, a lot is better. You do have the nail sealing portion of it. But what we're seeing, and you can see in this photo here, the hip ridge as well as the ridge is starting to rot out, because this is a conditioned attic space, does not have the traditional ventilation, and this interior moisture cannot dry through this vapor closed membrane. And then also same thing with your polyethylene on the interior of your walls. If you have moisture coming in, it's going to condense on the inside of that polyplastic.
Hey, Kaylin, that's a particularly ugly photo right there with that ridge. And I've seen that in remodeling work myself. And I'd just say that if there's some interesting things that have happened in the codes over the years. In cooling climates, there's the allowance for a vapor vent, if you will, and using a variable perm membrane at the ridge, closed, keeps airflow down, if you will, and drawing through the buoyancy of the attic space and all of that, but allows some of that moisture to get out. And something that we're interested in, our products haven't done testing to follow through on that, but as it gets into colder climates, it's a little more tricky and not quite as effective. But absolutely, shutting things down with plastics and other butyl wraps can be detrimental to buildings. There was
Jason, you're referring to the vapor diffusion port?
Yes, yeah.
Okay.
Very interesting stuff, but typically mixed and colder and warmer climates.
Yep.
Yes. Someone mentioned up to limited to climate zone 4 and maybe even lower than that. We did have another question earlier on, and I don't want to jump back too much, but someone had asked, Ken had asked about vapor variable perm performance membranes performing in a particularly wet area like a bathroom. Maybe that's something that you got right here.
Yeah, when some basic technology of these type of membranes, in most cases, they're a monolithic membrane. So this just means that the molecular structure of the material is designed in such a way that the water vapor molecules will follow this path kind of like a puzzle. And so that makes it extremely airtight, very watertight as well. And that path or that's maze that the water molecules are going through in a gas form, that changes based on relative humidity. So when you're on a lower relative humidity scale, those pores kind of close up a little bit more. So it's harder for those bouncing molecules to move through that chain. When you get into a higher humidity level, they kind of relax a little bit. So then it makes it a little bit easier for those water vapor molecules to move through. So if we are working in a high humidity area, like let's say a sauna or a steam shower, we do not want to use these type of products, because in that scenario, we are having a very high humidity, which means this product is going to open up and allow a lot of water vapor through it. So I wouldn't recommend this in a indoor pool scenario, or a wet sauna, or a steam shower would not be a good application for this product. And when we talk about the change in perm, with VaporWise, we're looking at the variability of 0.14. So this is just into the class 2 vapor retarder realm, and that is during the winter months. So lower vapor, lower relative humidity, and then it opens up to around about 14 perms in the summertime. So now that's we get a higher vapor permeance. And the key to that is if the interior wall cavity was, was damp during the winter, or it has moisture in it, that vapor openness now allows all that interior cavity to dry to both sides. Dries to the inward, also dries to the exterior. And that's why something like a TimberFill or a TimberBat is a perfect complement to this pass-through vapor strategy. Okay, yeah, can also be used with blown-in cavity insulation like the TimberFill. Reinforced, can be taped and sealed to create air control as well. If we were going to do an air strategy, we could do a self-adhered membrane on the exterior. That's a great exterior air strategy. We could also duplicate that and have an interior air strategy. So we would just have to make sure our transitions down to the subfloor, up to the roof line, everything is taped or sealed to make it as consistent as possible.
All right, okay, I got another round of questions here.
Yeah.
Let's go back to, do we have preferred details for different climates with different wall and roof types from Ed? I would say no, there's too many variables there from one to another.
So yeah, typically when we're looking at a recommendation of a assembly or a system or even any of our product lines, it always comes with a ton of other questions, because we want to understand, well, number one, your climate zone that you're in. We want to understand what type of exterior cladding or exterior roofing that you're using. We want to understand what type of windows that you're installing with, what type of interior insulation you're using, and what's your interior vapor control, so that we can understand how all these materials are going to move. If we are going to be using, let's say, a highly reservoir cladding on the exterior, like a veneered stone or stucco, then we mandate you must use a rain screen. That is your best assembly. That's going to reduce that high moisture content in a reservoir cladding from moving inward. Because again, we want to reduce the risk. And in that type of assembly, we want a lower vapor permeance product as your WRV. So it's just always a conversation about what is going to work best for the given assembly.
All right, I'm gonna jump to this one here. Todd is installing 2x6 wood framing to an unfinished concrete basement wall and installed timber bat insulation. It seems the VaporWise sheeting before the drywall. Do you agree, or should I remove the timber bat and treat the concrete first? In that basement, there is a heat pump water heater that helps dehumidify the space.
Yes, do you have a comment there? I can jump in.
Hey, Todd, how are you? I would say that, you know, really with below grade applications with bio-based material like timber bat, I mean, we're treating that with bore rates. I think that's an important part. It is pretty hydroscopic, so it can mop up some water. The fact that you have the space with a heat pump water heater probably mitigates some of that, is dehumidifying the space. But really, what I tell people with basement applications is that we don't outright recommend them. If you feel comfortable about kiln dried lumber as your framing in the basement, then you're probably going to be fine with our products in it. A lot of this is about airflow, and the materials that Benjamin Obdyke and others have to offer will mitigate that, and that's huge. So if we're keeping a warm area from getting to a colder space within and behind TimberFill or timber bat, that should help it. And it's really about outboard waterproofing and treatment of the foundation. In our builder's guide, we do have some assemblies that I would not outright recommend, like I had said, but in some parts of the country, it's more common to have drier spaces or proper foundation waterproofing and the confidence to address it there. So it could be all right. I don't think that you've gone too far off with it, but certainly VaporWise would help control that airflow and also help allow that moisture to release into the space where you have something that might work to dehumidify it pretty quickly.
Mhm. Yeah, and I think just to piggyback off what Jason said, that it when we're in a high moisture source like a foundation wall, the best course of action is to vapor close that wall from the exterior, because we want to slow the moisture that's in the ground from getting into our porous structure that is concrete or concrete blocks. That's going to be always your best. If it's a retrofit, I would highly recommend the interior treatment of the block or the foundation is your next best assembly. If you have a French drain that anything can weep down into, it's really trying to prevent that moisture from getting inward. In that application, a vapor closed membrane would be a better solution because you have so much moisture moving from the outside in.
Right, right. Yeah, assurances that it is dry in the first place is I think
Yeah.
the first step.
Mhm.
One of the things that we have in our detailing in the builder's guide that may not be extremely apparent because there's thin little lines, but it's just a vapor throttle in between. So if you have done what Kaylin's suggesting on the exterior of the block or more likely poured foundation, and you really feel confident that footing drains are in place, you could add a vapor throttle by having a variable per membrane or a flashing of some sort that is coating that, just to slow it down, to keep it from migrating into framing and other wood products in the wall assembly.
I agree. I like it.
All right, one more here, and we also had some more questions around around Sega's Madrex comparison, so we'll get to that later. Building Charlie Kelly's wall assembly, Climate Zone 5, all of his, basically, I mean, he listed everything here, but all of his wall assembly materials are vapor open materials. So given that everything in his assembly is vapor open and moisture tolerant, is an interior vapor barrier still necessary?
So in Climate Zone 5, you must install a Class 2, I believe, interior vapor control. So that could
And that's
be a
outlined in the
multitude.
IRC chart, correct?
Yeah.
Yeah, I
Mhm.
mean, he might be addressing this. It's vapor open is lime plaster over hemp board on the interior. Vapor open insulation, wood fiber, wood sheathing, tar paper, weather barrier. So you could address it by having a continuous exterior and adjust the dew point potentially of the back of the sheathing. But that when you get into 5, 6, 7, it gets to be more than what you are required by just the thermal value of it. You need enough to actually mitigate dew point. But I would say that having interior vapor barrier not required or beneficial necessarily, retarder or certainly variable perm would be beneficial, and a lot of that is airflow control as well.
Yep. Perfect. So yeah, I just want to run through these last couple slides, and then I think that's about it. And we can definitely spend the rest of the time. I know we're getting close for questions. Just real quick, so this was our vapor dry essay. This is something that we saw a need for in terms of the trend for a vapor closed self-adhered roof underlayment being used on the full roof deck. So this is a vapor permeable, fully acrylic coated self-adhered WRB that can be used in code compliance for ice barrier applications at your eaves and valleys, and also approved for the entire roof deck. And the benefit of this again is it's liquid water can't go through it, air can't go through it, but water vapor can move through. And this one again falls between that 10 and 20 at 14 perms. So this is something we're gaining a lot of traction just based on the education and a lot of the failures that we're seeing out there for that roof deck application. And then our HydroGap SA, we had somebody that mentioned a air control strategy with a self-adhered membrane. HydroGap SA is a perfect air control component on exterior strategy while still being vapor open. So airtight, vapor open, and allowing for that drainage path is a great option for a lot of our higher performing building assemblies. And then anytime we can add a rain screen to the wall or something like cedar breather to the roof, we're now dramatically reducing the risk because any interior moisture that's moving out is moving into an air cavity, so that could then lead to more drying potential is really the key that we're looking for in these building assemblies.
There you go.
Yeah.
One of the questions we had was whether or not you could provide your email at the end. So I think
Yes, got it.
Sure. Our TimberHP, we are first name, last name at TimberHP. So Jason period Todd, I can put that in the chat. Happy to share that as well. And if you want to add any more information for the group as a whole. Any other questions out there? We could even open up the mic if I can figure out how to do that. But it's been a good conversation overall. You got Nick's
Yeah, a lot of great questions. I
contact in
appreciate
there.
it. So yeah, let's see.
I think we've got just about everything covered. John at the end did talk about new codes and applications with spray foam, and just feeling that the best answer is correct installation of spray foam. And I think there's a lot good to say in good applications of everything. I still feel pretty strongly that vapor open assemblies are beneficial, and sometimes it's so vapor open we need to throttle down a little bit. So having something that's variable perm is very helpful. So
Completely agree. So yeah, it looked like we had some questions just based on product specifics in terms of some of the interior vapor membranes.
yeah, I think one of them was Myricks, and someone might have suggested that was directional. I believe it goes both ways, and I'm thinking that's how your products work as well. Maybe comparing to a couple of others out there. I know that was asked a few times.
Yeah, it was Siga's Myrex, Certainteed Membrane, Proclima's Intello, and then the Rothoblast.
Right. Yeah.
Yeah, I can't speak to the exact performance of all of those, but I know that in basically if they are designed for a blown in type insulation like TimberFill, that they are more reinforced. Because I know that certain teeds you cannot do that just based on the material itself, but all of those products will work in the smart vapor range as far as limiting the amount of interior moisture to the exterior and then opening up in the summer to allow that vapor permeance.
Well, thank you, Kaylin. Thank you, Nick. I would encourage everyone to look for future conversations, to reach out to any of us for follow-up questions. It is after the top of the hour, so mindful of everyone's time. Appreciate it. And yes, this will be available. I believe you'll get a link to the presentation afterwards as a follow-up, and or we will be archiving it online. So thanks again, everyone. Have a great rest of your day.